SOLIDWORKS 2017 introduces flexible and powerful new workflows when working with third-party design data with 3D Interconnect. 3D Interconnect streamlines collaboration with your customers and supply chain regardless of which CAD tools they're using. It also allows you to leverage any legacy design data created in a variety of CAD formats. 3D Interconnect is much more than 3D translation. In fact, it virtually bypasses the entire translation process and allows you to work with CAD data from a variety of design tools as though they were native SOLIDWORKS files. It's also intelligent and understands when third-party CAD data is changed within its native design environment by honoring face and edge IDs, and changes to these files are like changes you would make in SOLIDWORKS. File formats utilized by 3D Interconnect also open significantly faster than traditional translation processes and likewise eliminate the additional tasks often associated with those workflows as there's no additional files to manage. Let's look for a moment at the various file formats that are currently supported by 3D Interconnect. These include PTC Creo, Autodesk Inventor, Siemens Solid Edge, and NX, as well as CATIA V5 for SOLIDWORKS Premium customers. In this demonstration, we're going to look at 3 different workflows to show just how flexible working with third-party CAD data is with 3D Interconnect. The first workflow focuses on directly using 3D files in SOLIDWORKS assemblies, like any other SOLIDWORKS file, and is probably the most commonly used method of leveraging 3D Interconnect. In this case, a battery pack assembly was designed in Autodesk Inventor that we need to incorporate into the Myomo control module designed in SOLIDWORKS. This could have been designed by a vendor or possibly using a legacy design tool like Autodesk Inventor. Within SOLIDWORKS, using these files is exactly like inserting any other component. You'll notice, however, that the Insert Component dialog box now includes the previously mentioned file formats and the filter list for easier navigation. We'll choose our Autodesk Inventor assembly in this case. The file is inserted just like any other SOLIDWORKS component. No translation steps necessary. All of the geometry is there, not just a representation, actual 3D models. Looking at the Feature Manager tree, you can also see that the entire assembly structure is available as well, though notice these icons are slightly different. These icons signify that the component is referencing the actual third-party CAD data. We can use this assembly like any other SOLIDWORKS assembly, mating it into place, in this first case using the provided reference planes. But because we have all of the 3D geometry, we can mate to any surface on the components, just like you would any other SOLIDWORKS files, allowing you to work the way you expect. We've also incorporated some design intent into this retaining bracket. Notice as we mate the back face of the bracket that the countersink holes and rivets along the side move with it. This is important as we've established some design intent here that ultimately references back to our Autodesk Inventor assembly. Now that the design is in place, let's look at how 3D Interconnect handles changes that take place to the native CAD geometry. Within Autodesk Inventor, we've made several changes to both the parts and the assemblies. You can see that not only are the batteries longer and much bigger in diameter, the housing has also changed. It also now only includes 6 batteries and a much more rounded housing to contain their larger size. To simulate the change without Autodesk Inventor, we're simply going to overwrite the existing files with a new version we have on hand. When we go back to SOLIDWORKS and perform a rebuild, you'll notice there's now a small refresh icon on the assembly, letting us know that it's seen a change in the native CAD files. To update the models, all we need to do is right-click on the assembly and choose Update Model. SOLIDWORKS then updates the assembly as well as all of its child components. More importantly, notice that all of our mates in the assembly update properly and the countersink holes and rivets move accordingly, honoring the design intent we established. This is probably the most common workflow that users will want to take advantage of immediately, but 3D Interconnect offers other ways to work with your third-party CAD data. Let's take a look at another, directly opening a file and using it like a derived or base part. In this case, we'll be working with a pulley designed in PTC Creo by a vendor. We will need to add some of our own features that are added after we receive the actual part, in this case a keyway and a hard stop slot. We'll also show how 3D Interconnect handles changes within this scenario and how it also handles PTC Creo Versioned files. This time, instead of inserting a component, we're going to open one directly, this PTC Creo file. Notice that the file has a unique suffix of .1. This is how PTC handles revision changes and will come into play in a moment. For now, let's just open the file. Notice this time that the top level file is an actual SOLIDWORKS part. However, instead of a traditional imported geometry feature, we get a base or derived part. It has the same unique icon as before, letting us know that it's referencing the native CAD data. In this example, I'll just add a couple of library features to quickly place both a keyway and a slot on the inside surface of the pulley. The important thing to note here is I'm dropping these onto faces of the part and I'm referencing an edge in both cases, both things that may have caused challenges in the past. We will also add this pulley to our control module assembly by simply dragging and dropping it into place, and then making any adjustments as necessary. As we do so, we can clearly see that the slot doesn't line up properly with the hard stop in our design. At this point, you may need to call the vendor and have them make a change in the native CAD tool. In the case of PTC Creo, however, instead of just overwriting the existing file, you'll often be provided with a .2 or similar version file. When we return to SOLIDWORKS and perform a rebuild, like before, you may notice there's a refresh icon on the derived part in the Feature Manager tree. Just like before, we'll right-click and choose Update Model. In this scenario, we have features that reference the native CAD data, and like before, they update with no errors. The same is true when we activate the assembly again. This means we can bypass the lengthy import and repair process completely and focus on our designs. For our last scenario, we're going to look at how to break the link to the original CAD data and work with the files in a mixed environment. This may be to add our own features to an assembly component, or to do more elaborate work, like perform FeatureWorks recognition on a specific component. In this case, we're going to import another assembly, this time from Siemens Solid Edge. The file in this scenario has come from an online vendor, and we don't have the luxury of making changes to the native data in its original design tool. As you can see, however, there's a hole that doesn't line up properly. In this example, we want to move the hole so we can have our own adapter plate manufactured for this circumstance. This is a case where we may want to break the link to select component files to make our own parts and assemblies. To do this, you simply need to right-click on the assembly and choose Break Link. In the Feature Manager tree, you can see doing this made a copy utilizing a virtual component, which you can save externally if you wish. If we open this assembly, we can see that it still references the native components that it's comprised of. For this example, however, we also want to break the link to the adapter plate. Before doing so, notice that these components are like the previous example, where they use base parts. When we choose Break Link on this component, however, you'll notice that it now resembles a traditionally imported file in SOLIDWORKS being comprised solely of an import feature. With our part, now a standard imported SOLIDWORKS component, we can make changes to this part using powerful SOLIDWORKS direct editing tools. In this example, I'm going to use FeatureWorks' automatic feature recognition to turn this hole into a SOLIDWORKS hole wizard hole. The center of this hole isn't properly located, however, so we'll return to the assembly where we can edit the sketch. And then we can properly locate our hole center concentric to the existing hole in our design. This is just another way to leverage the powerful new 3D Interconnect technology in SOLIDWORKS 2017. We've shown 3 different workflows that will be greatly appreciated by most SOLIDWORKS customers, but there are many more possibilities. So to recap, 3D Interconnect provides extremely powerful new ways to work with your supply chain, customers, and files you download from the internet, virtually removing the concept of file translation altogether. More importantly, 3D files from third-party design tools are intelligently monitored to make sure changes are propagated properly, just like any other SOLIDWORKS file. And finally, SOLIDWORKS 2017 provides many new flexible ways in which to leverage this new technology.